right, so in our last video, we learned what a wave is, and we also learned about different vocabulary we use to describe a wave. In this video, we're going to learn about how we can use that vocabulary and how we can use these different equations to further describe a wave's motion. So our objective is to be able to analyze the motion of a wave by calculating its frequency, period, wavelength, and velocity. And our essential question that you all should try to answer in a summary at the end of your notes is, how do we describe a wave's motion? So let's start off by reviewing these two concepts of period and frequency. So you all should be pretty familiar with period and frequency because we've gone over this before. But remember, the period is the time it takes for a wave to complete one cycle. So now we're going to learn about how to calculate period. So our variable for period is a little bit odd. It is a capital T. Again, I'm assuming it's because lowercase p was taken by momentum already. So we're going to use a capital T as our variable to represent a wave's period in our equations. Now, our equation for calculating period, we are going to use T equals 1 over F. So this is a little bit odd because we don't know what F is yet, but I can tell you in just a moment, we will know that F stands for frequency. So the period of a wave is 1 divided by the wave's frequency. Okay. Our unit of measurement for period is seconds, because period describes the time it takes for a wave to complete one cycle. So we measure time in seconds. We are going to measure the period of a wave in seconds. Now, we also are familiar with this concept of frequency. Frequency is something you all have learned before in the last video. Frequency describes the number of wave cycles that pass a given point in a certain amount of time. Now you'll see that lowercase f. This is what we are going to be using to represent frequency. Now I do want to point out this is a lowercase f. It's a little f as opposed to the uppercase f that we use to just use for force. Okay, so lowercase f for frequency, uppercase F for force, which we learned last semester. All right, our equation to calculate frequency is actually going to be 1 divided by the period of the wave. So this is, hopefully you're starting to see a little bit of a relationship here. To calculate frequency, we divide 1 by the period. To calculate period, we divide 1 by the frequency. We'll talk about that relationship in just a moment, okay? This is a new unit of measurement we use to measure frequency. It is called hertz, not to be confused with the rental car company. I actually have no idea if those two names are related, but hertz is actually 1 hertz. I'm gonna make a little note of this because I think this is kind of cool, so you all can kind of see how we get some of these units of measurement. So 1 hertz, which we use Hz as our abbreviation for hertz, 1 hertz is actually equal to 1, I'm going to draw 1 here, 1 divided by a second, all right? So a hertz is actually the reciprocal of seconds. All right, so we can also write that as seconds to the negative first power. So you all can kind of see that relationship here. So 1 hertz is equal to 1 over seconds, just like we calculate frequency as 1 divided by period, which is measured in seconds. Right, so hopefully y'all are kind of starting to see that relationship there. So this relationship, and I'll zoom in so y'all can get a better sense of this. This is what we call an inverse relationship, meaning that both of these variables are related to each other, but they tend to grow or increase or decrease in opposite directions. So as period increases, frequency decreases. So we can kind of see that play out here, right? We've got, and I tried to represent this visually to show this is a big letter T. You can kind of see that period is increasing, and then here's our smaller letter F to show that frequency is decreasing. Now, if you think about this mathematically, this does make sense, right? This is a division sign, 1 divided by period. So the larger period, the more you are dividing by. So that's going to actually create a smaller fraction, right? So for example, say period was 2 in one case, and then it became 16 seconds in the next scenario, right? This fraction, which will be our frequency now, is bigger than this fraction, right? So you can kind of see that relationship. And the same goes for calculating period as well. The higher frequency, I'll draw a big box with the big letter F for frequency increasing, the smaller the period is going to be. Again, you're dividing by a bigger number in frequency. So our period is going to be smaller. It's going to become a smaller fraction there. Okay, so we've learned about period and frequency. Now we are going to get into, now there are many, I do want to clarify, there are many different wave equations. This is going to be our main equation that we will be dealing with in this class. But this is our primary wave equation. So this equation is right here, right? Which says that the velocity of a wave, remember V is for the velocity, is equal to the wavelength, and this is, I'll explain this in just a moment, times the frequency. All right, so this little weird sign right here, and I will, this weird sign for wavelength, and I'll point it out right here. So again, this is actually representing wavelength. Actually, I'm going to back up. This weird sign that represents wavelength is actually the Greek letter lambda. So I'm going to write that out for you all so you can see that. This is the Greek letter lambda. So we do still use some Greek letters, right? Another one you all know is delta, right? That means change. Okay, so this is a new Greek letter. If you all are not familiar with your Greek alphabet, this is called a lambda sign, and it represents wavelength. That's actually our variable for wavelength. All right. And then we are familiar with some of these other variables, right? So V is for velocity, which is measured in meters per second. Frequency is measured in hertz, which we just learned. And wavelength, because it's a length, is measured in meters. That's how we measure the length of something, right? So this is a nice 3 variable equation. So we can actually use our triangle trick when calculating this 3 variable equation. So again, whatever is on its own side of the equal sign is going to go at the top of our triangle, and then the 2 variables that are being multiplied together. So again, this means that they are being multiplied. I'm going to draw a little multiplication sign. Those are being multiplied together to equal velocity of the wave. Okay. So let's think about how all of these equations that we just learned, we actually just learned 3 equations, how we can use these when solving for various components of a wave. So we'll go through an example problem together right now. This says an ocean wave has a period of 1.5 seconds and a velocity of 3 meters per second. Calculate the wave's wavelength. So again, I'm going to go through our standard 4 steps to solving a physics word problem. I'll draw a picture of the wave. Okay, and I know that our wavelength, or excuse me, our period is equal to 1.5 seconds. I'll actually highlight that in there as well so you can see where I'm getting those numbers. All right, and the velocity of the wave, which I'll put here in green, the velocity of the wave is 3 meters per second. So I'm going to write, velocity equals 3 meters per second, right? That's all we really need to do for step number 1, because I'm not seeing any other numbers given to us in the problem. I can move on to step number 2. All right, so step number 2, we're going to write out what you know, write out what you don't know in the problem, okay? So we know that the period is equal to 1.5 seconds, and we know that the velocity is equal to 3 meters per second, right? The problem is asking us to calculate the waves, and I want to highlight that in black. We want to know what the wavelength is. So remember, wavelength, our variable for wavelength is lambda. So I'm going to write that lambda equals question mark to indicate I don't know what lambda is. Now, we're about to run into a bit of a problem, right? Because normally I would say, let's go ahead into step number 3. Let's use our triangle to solve for lambda, right? And we have frequency times lambda here, give us velocity over frequency is equal to lambda. But we got to back up for a sec because we don't have frequency. So how can we solve for lambda here if we only have velocity? So what's going to actually happen is that we need to solve for 2 equations, right? Thankfully, we know how to calculate frequency. So let's also put that we don't know what the frequency is. So we actually want to start with calculating frequency because we cannot calculate wavelength without actually knowing the frequency. Okay, so the first thing I'm going to do is calculate the frequency of a wave, which if you recall, our frequency equation is 1 divided by the period. All right, so we can go ahead and actually going to have 2 step number 3s and 2 step number 4s. So we can go ahead and plug in what we know for period here. All right, thankfully the problem did give us a period. So I'm going to write F is equal to 1 divided by the period, which is 1.5. And that should give me a frequency of 0. And I'm going to round. It's actually 0.66666 and so on. So I'm going to round to 0.67 hertz. Right? That is my frequency that I'm going to be using. Okay, now that we have our frequency, we can use that for solving our second round of steps 3 and 4. Okay, so now we're going to use this. Start at step 3 again. Okay, I'm going to draw that triangle again so you all can kind of see how I am using this equation, right? So remember, the velocity of the wave is equal to the frequency. Actually, I'm going to back up because I think I had it with lambda on this side. Okay. All right. So remember, with our triangle trick, we are covering up what we don't know. So I'm going to cover up lambda to indicate that we do not know what lambda is. Right? You can use your finger, you can use your hand to cover up what you don't know on the triangle. That gives us this equation here, right? Lambda is equal to velocity divided by frequency. So I'm going to write that over here. Lambda is equal to velocity divided by frequency. Now, thankfully, we have a velocity and we now have a frequency to plug in. Okay, so we are good to go to move on to our second step, number 4. So I'm going to rewrite this equation as it is. Okay, and again, I'm taking this frequency here and plugging it in where it belongs for frequency in this equation here. So I'm going to plug in my frequency as 0.67, okay? And then I'm going to plug in my velocity where it belongs. I meant to be on highlighter mode. So here's our velocity, okay? And I'm going to plug in our velocity, which is 3 meters per second. And now we are all set up to go ahead and plug this in on our calculators and solve for 3 divided by 0.67, which is going to be equal to 4.48 meters. That's our wavelength for that ocean wave, 4.48 meters. All right. So that was a pretty complicated problem. I hope that you all were able to follow along with some of those steps. Again, what we did is that we were solving for wavelength, but we realized that we actually needed to solve for frequency first before we were able to solve for wavelength, since the problem only gave us period and velocity. So we kind of did 2 rounds of steps 3 and 4. We first solved for frequency. Once we solved for frequency, we are able to plug that back in to our wave equation and solve for the wavelength there. So I'm going to zoom out so you all can see all of this, all of these equations again. So we have learned how to calculate period, frequency, and velocity, wavelength, and of a wave. All right, so accomplished our objective today. Again, before you all finish up this video, please make sure you write a summary, about a 1 to 2 sentence summary about what you learned from the video, trying to answer that essential question. How do we describe a wave's motion based off of what you learned today? And I look forward to discussing this more with you all in class.